Okay, everybody, let's start with the basics. So we'll start by simply creating the project. So as you can see, I'm using Unity Hub 3.7.0, and I'm going to create a new project. Be careful to use one of the LTS versions, so 2022.3.17 for my case. And I will be creating a dots training project. Let's call it like that. And I will be using the 3D URP core rendering pipeline and template. I'm not connecting to Unity. And yes, WinGames. Create the project. Okay, so now we have an empty project. You can see there are still a few error messages as usual, but never mind. The first thing we will do will be to import the package. So for that, you can go to the package manager here. Keeps opening on the wrong side. And what you want to be looking for is in the Unity registry. And you should be able to look for graphics and get the entities graphics package. Let's install it. So basically this package handles all the communication between the ECS world and the rendering pipeline, either Universal Render Pipeline, HDRP, or even the built-in pipeline. And it also has all the dependencies to other dots packages. So a common misconception is that dots is ECS. In fact, no, dots is the data-oriented technology stack, which includes the ECS package, Entity Component System, but it also includes the burst compiler and the job system and collections package to have some native containers usable in the jobs. Okay, so if I look at the dependencies, as you can see, we have a dependency with the entities package. And if I remove the filter and go to my project, as you can see, we do have the entities graphic. We also have the entities package, the burst compiler, the collection package. The job package has been included as part of Unity itself. So it's no longer a standalone package. That's why we don't see it in the package manager. Okay, so we have the package. We want to learn dots. The next thing we want to do is for ECS to do some configuration. So we can go to the preferences, edit preferences. And inside entities, we want to make sure that we are on the runtime data for the scene view mode. And basically, you have the choice between runtime data and authoring data. And if you don't select runtime data, you can have issues with not seeing some objects in the scene view. So always select runtime data. Next, what we want to look at is not in the preferences, but in the project settings and in the editor you can go down a little bit here, and you can enable the interplay mode options. So basically, this will remove the domain reload and the scene reload when you start, you press play. So it speeds up your iteration when you try to implement some new stuff. But it also has, as the tooltip mentioned, the side effect. No, it's not even mentioned in the tooltip, in fact. You need to be careful with any static data that you can have, because it will be kept until there is a domain reload, and the domain reload will only happen when you have basically new code that is compiled. If you have a lot of static data and you want to still have the domain reload, you can check the domain reload domain option. But the fastest option for increasing your iteration time and your tryout time interplay mode is to select just the enable option. Then what we need to make sure of is for the graphics, in fact. So you can go to graphics. Here you can see that I have the URP high fidelity that is selected. So I can click on it and it should normally open it. The project view, let me check. Okay, it selected it in the project view. Here you can click even further on the renderer list. And here what you want to select is for the rendering path, you want to select the forward plus. That will enable better compatibility with the Unity entities graphics. So keep in mind to set up this. And of course, if you have the balance, same thing. If you switch the URP profile, you need to also set the forward plus on the other profiles. Okay, we are almost done with the setup. The next thing I want you to do, if you want to follow this this course, is to download some assets from the asset store. So as you can see, there are all free assets that we'll be using throughout the course. I will put a link in the description. It's an affiliate link, so it will help me support the channel if you buy something else while you follow the course. But all of these are free, so you can go ahead and download them. I will do that and speed up the video so you don't have to go through all the imports. See you in a few minutes. Okay, everything is imported, so I can close the package manager. And now if you take a look at one of the package, you will see that all your materials are pink. So what you can do is go to Windows, Rendering, under Pipeline Converter, open that in the correct window. And here you can select everything and click on Initialize and Convert. So that will convert from built-in to URP for all the materials. And as you can see now, the material are no longer pink. You can check for other package also. Not for sprites, for the visual effects also. So everything seems to be okay. What I like to do also is to create a folder for third parties. So I can put all my assets from the asset store in the asset folder, in the third parties folder, sorry. Okay, I have everything, I can move them. And it makes things a bit easier to look at. Okay, now we are almost ready to start the learning process. So what I want you to do now is to go to the GitHub that is linked in the description of the video. And you can download the first package. So for me, I will just copy and paste it. You can download the first folder, which is the else regen folder. And normally, if you open the else regen scene, not the subscene, be careful, open the scene. And now if you go to the scene, you should be able to see in your scene and in your game view a little slime. So the setup is complete. We can start learning about Unity Dots and Unity ECS in particular. So ECS stands for Entity, Component, and System. What is an entity? An entity is basically just a number, an index, or an identifier of something in your game world. The component or the actual data structure that holds all the information about the entity. So it can be the position, rotation, health, experience, whatever you want to have in your game. And the systems are actually what acts on the components. So if you need to transform the component value, so if you need to move your entity, you will need to act on the transform components, on the position of the entity. So you can view all of these concepts here in the window entities, and you can see we have the hierarchy, which is similar to the game object hierarchy, the components, which will allow you to look for all the components that have been defined in your ECS project, the systems, which is a window that will show you basically all the system and the organization of the system, so the full player loop. We can see we have the initialization, update, pre-late update with the presentation system group. In the simulation, we have a bunch of systems, including the transform system and fixed step simulation system. So all of this is your player loop or your game loop. ECS gives you much more control on the execution order of your actual player loop than it did with than Unity did with game objects. So that's great. And if we look at the other specific entity windows, we also have the archetype window. So the archetype window allows you to see all the elements of your game or all of the objects in your game that have similar sets of components. Basically, an archetype is a set of components. So if you have, I don't know, a player that can move and be damaged, it will have the transform components and the else component. It will also have the rendering related component, of course, otherwise you wouldn't be able to see it on screen. So the first thing you will notice in the hierarchy is that we have the scene opened, and we have something that is called the subscene. So you have to know that for every entity to exist, you need to put them in a subscene. So here you can see I have a subscene. It's not opened. So I can click on the checkbox to open it. And as you can see here, I have a regular game object where I can define the mesh filter, mesh renderer, and other types of mono behavior components. If I click on play, nothing much happens because what you're looking at here is the authoring representation. So the component that you manipulate when you design your game. And if you click on this little circle on the top right, you can actually switch the view. So automatically it will go to authoring, and you can switch to mixed or runtime. Runtime will show you all the components that your entity has in the runtime. So the components that are modified by the systems. As you can see here, we have the else component that is being increased until it will reach the max value of 1000, and it's increased based on a 10 point per second value that is defined in the else region. If we look back at the authoring component, we can see that it's enabled because we have the authoring component, the damageable authoring component, which sets the max else at 1000 and the regeneration speed at 10 points per second. If we open the system window, let's dock it here, and we look at the else system, we have the else regeneration system. We can click on it and see that the else regeneration system, so here you can already see that it's acting on one single entity. It also gives it the timing, but don't be very attentive to that timing. It's better to use the profiler that we'll see in a later video, and I will explain why. But you can already see that it's acting on a single entity, and that for it to act on that entity, it means that this entity has the else component, which is accessed in read and write, and the else regen component, which is accessed only in read. You can look at the relationships, and you can see that for that query number 1 here, we have one entity, which is the slime. And you can go back to the slime and see that the entity, okay, if I click on runtime, sorry. If you are selected in runtime, you will see the ECS components of that entity. For the hierarchy, you have the hierarchy for the game objects, but you also have, like I've said, the hierarchy for the entities, which is similar. You find again your main scene and your subscene with the components, but you also have a lot of other entities that are defined by the default game loop, including, for instance, the world time. You can find the world time. If you stop playing, you will see the converted initial view, so the baked entity. And if we start play, you can see that it's increasing the else. And you do that through a system. So now if we have a look at the code, as you can see, I've organized the project, and all the folders for every step of the project will have the same folder structure. So we have the authoring folder, the components, mono behaviors, prefabs, resources, scenes, and systems. So I will start with what we can see here. So first we have the authoring components. So as I said earlier, the damageable authoring is an authoring component. It's a component that allows you to define or design your game. These components are aimed to be designer friendly, so it doesn't necessarily map one authoring component to one ECS component, because sometimes the most efficient representation of the data for the computer to process is not actually the easiest to think about when you design the game. So the authoring workflow and the baking workflow, that's what it's called. So the authoring component are there to present a designer-friendly interface for you to design the game. If we have a look at that component, here I'm using Rider, but you can use any other code editor you want. And as you can see, it's a mono behavior. I've made a distinction between the authoring and the mono behaviors because basically the authoring are not meant to be executed at runtime, whereas the mono behavior are the usual game object components that can be executed at runtime. But for the baking workflow, so the process of taking your game object component and converting them or porting them to the ECS world, which is called the baking workflow, I'm using for those authoring components, for those game object components, which are authoring component. For those authoring components, I put them apart because they are only executed or used during the baking of the subscene. So as you can see, we have the max else and else regen. If I hide this part, that's all we have. So there is no update loop, there is no start, no awake, no undestroyed, no other methods that we usually have for game objects. What we do have is a nested class, which extends the baker class, which is a generic class that takes in the authoring component. And in that subclass, we have a bake method. And in this bake method, that's where we define our entity and our ECS components. The first thing we want to do is to get a reference to the entity we are currently baking. For that, we use the getEntity method from the class, the parent class baker, and we pass in a transform usage flag. So, what is the transform usage flag? It's something that will allow the baking workflow to know if that entity requires any specific components related to its position in space. So here, since I'm doing just a damaging behavior, so I just want to be able to have some else that will be able to be decreased and regened by a system, I don't really care where the entity is in the world. So that's why I'm using the none flag. I've listed all the possible values and what they will give you as ECS components. So if you want some things to be rendered, you'll need to use the renderable flag. And basically it will give you a local to world component. Alternatively, if you just have an entity with a mesh filter or mesh renderer, it will give you automatically this because the baking workflow for those game object components mesh renderer already takes care of that. If you want your entity to be able to move in space and not be static, basically you need to put in dynamic. If you don't want your entity, or if you don't need your entity to be able to move, but you still need to have a world location, the transform component, basically, a position in space, you can use the world space. If your entity requires non-uniform scale, you can have the non-uniform scale flag. And if you want to take full control over what components you will have, you can use the manual override. And in that case, it doesn't matter whatever other baking component or a baking process ask, you will have full control over it in your baking process here. So now that we have our entity reference, what we can do is define our new components, our new ECS components. And you will see I have two values, one game object component, and I will end up with multiple components and even more values. So the first component I want to define is the else component. So if I look at the else component, which you can do by control clicking, or you can find it also here in the components folder, you have the else component and else regen component. But going back at the else component, you can see that it's a struct. It's a struct, it's not a class, and it implements the iComponentData interface, which has absolutely no method. So it's just a way to identify the type of component we have. We'll see in the next video another type of component. What you need to be aware of is that for ECS to work, you need for the component to only have what is called bleatable data. Essentially, that means primitive types. You can have more information about bleatable types in this link. And yeah, essentially, basically, it means bleatable types or other structs that only contains primitive types. So I've defined a current else, which will be my current value, and a max value, which will be my max value. So since it's a struct, I can create a new instance of it with a default keyword and set the else max value to the max value I have from my authoring component, so which is this one. And by default, I set the current else to be half the value of the max else. So I've defined my data, but it's not yet linked to the entity or associated to the entity. So I need to add the component to the entity. So I call the add component method, passing in the baking entity, which I'm currently converting or processing. And I give it the else component that I've just created. I can do the same thing for the else regen. And in that case, I'm just doing it in a single code, so it's a different syntax. But as you can see, it's exactly the same type of component. We just have a struct, else regen, which implements the iComponentData interface. And that just has the number of else points I will regenerate per second. Okay. So if you just do that, and put the damageable authoring on a game object in the subscene, you will essentially have created an entity with the components else and else regen, plus any other component that is automatically added by other rendering component or transform components. That's great. You have your entity, you have the value in place, you can see them in the inspector. But how do you go about increasing the else over time? So like we said, what acts on the data are systems. So here I've defined a system, which is the else regen system. And if we open it, you can see the syntax for that. So same thing, the system are partial structs. Why are they partial? It's because the way Unity implemented ECS involves quite a lot of code generation. And basically they use the partial feature of C# to be able to define the rest of the implementation that is code generated in other files. But you have to be careful to not forget the partial keyword. If you forget it, you will get either a warning or a compilation exception, so you can't forget about it. Using a struct, which implements the iSystem interface. And in the iSystem interface, if I click on it, you can see we have the onCreate, onDestroy, and onUpdate. All of them are having default implementation, so that's a feature of C#, meaning that you don't actually have to implement all the interface. So if you just create an as system, which is empty, it's valid. It will compile. If you want, you can implement the onCreate. On start running, you don't have it in the iSystem, but you have it in the iSystem start and stop. So if you wanted to have a specific code executed on start or on stop, because you also have the on stop running, and the on destroy. What I will be focusing on today is just the on update, because I don't have anything to do on create or on destroy yet. We'll see that in future videos. But in the on update, I will define basically the behavior I want this system to perform. And for the else regeneration system, what I wanted to do is to find all the entities that have else and else regen component. You can see here, and increase the else of the entity based on the value of the else regen. So here, if I want to explain the syntax, as you can see, it's a for each, so it's a loop. It will loop through what? It will loop through every entity that match this query. This query says, okay, I want to have access to entities that have an else component, and I want to read and write to that component. And I also want the entity to have the else regen component, and I want to be able only to read from that component. I won't write to that component, so I just get it in read only. This is written in a tuple, so I can a value tuple, so I can name them however I want, and then I can have access to them. What you need to be aware of is that here, what we are querying for is not actually the else component, but it's a reference wrapper to the else component. So when we want to access the actual value of the else component, we can't just do hprw.current for the current value. We have to use either value RO to get the read-only value, or value RW to get the read and write value, so to be able to write to the value. And basically here, all I'm doing is defining the new else for the entity to be the current else plus the number of points per second that it should recover times the time that's been elapsed. And here I'm also using the system API to get access to the time component, or to the time entity of the ECS world. And then I'm affecting the else value to the else component based on whether the new else is lower than the max else to avoid. Okay, that's it for today. If you liked the video, don't forget to like, share and subscribe. And I will see you in the next video where we'll learn about the dynamic buffer and the burst compiler. See you next time.